Advanced REST and HTTP status code headers and best practices for scalable RESTful APIs. Today we will cover some theory, some basic ground, some advanced concepts on HTTP and REST services. And yeah, I would say let's go. The point of this video is to give everybody a bit of a better understanding of REST and HTTP and to advance your knowledge on these topics. And also we will do a couple of experiments where we will show the things that I'm telling you here in the browser in actual web services. Okay, so where do we start? First of all, REST and HTTP, most developers know these things. Usually what is known is that REST requests or HTTP requests are usually get, post, put, or delete. These are the usual change, read, update, and delete type of operations. Many web apps only use these and work fine. Get requests retrieve information from a service. Post requests, post information to a service, put requests, put information into a service, and delete requests, delete information on a service. These requests are quite publicly known, and you can do practically everything with them. You can base your entire application just on these couple of requests. These are requests implemented in HTTP or are wrapped in HTTP. And yeah, that's it. But there are many more methods and we will cover some of them right now. There are advanced HTTP methods such as patch, options, and head. The patch request, for example, is similar to a put request, but not quite the same. A put request is used to update resources, as the text says here. You will put information into a resource, replacing the information already available. So a put places information into your resource. A resource is any information available at the server side, at the backend. And a patch request is a request that indicates how a specific resource is to be changed. For example, if a resource at the server tracks, for example, Formula One races, then the resource models the car models available, the amount of cars and the times certain cars accomplished. And a put request would, if you say, for example, let me think of something good. Put the time of that car to this value. Then the value of that car is set. Or depending on the service and depending on how it's implemented, a put request would have to override the entire car, which includes the time property. If you, however, have a request or a value that changes depending on the previous state, you can use a patch request. For example, the amount of cars on the track decreases by 1 because one car had an accident. Then a put request would rewrite all the cars. That's also a bad example. And a put request would override the value for the amount of cars. A patch request could, however, be in an increment or a decrement change. So you could say decrement the amount of cars by 1. Of course, if you track the entire situation, then the patch request would also have to specify to remove that car from the list of available cars, but that would be possible as well. A put request, on the other hand, would have to replace the entire situation. So put requests usually write a lot of information, they transfer a lot of information. Patch requests carry only the changed information or instructions on how to change the information that is already available. So patch requests are much faster. It's a similar concept to when you have whatever bug in an application. You don't wait for the next full version to be released. Instead, you release a patch version where just that bug is fixed, or you release a patch jar file or a patch source file, and that patch source file patches just the place you want to change. You don't have to overwrite everything. That's a patch. Patch repairs locally, put replaces everything. Okay, so that's the patch request. Quite interesting, I find. Another one would be to request or to use the head request. That is when you want to check resource headers without downloading the entire body. Okay, so whenever a resource, and depending on what your resource is, but a resource could be, let's say, a video file. And a video file consists of the video data itself, but it also has headers, which would be the length of the file extension, the encoding, the specific time tags with descriptions, chapters. These could be header data, and the head request requests the resource header only. For example, if you have a video service that streams multiple videos or that streams a video database, then when you go to the start website, the homepage, then you want to display the videos, but you don't want to download all videos already. So you can request the headers of the videos. So also that's both the patch request and the head request, they both follow the same basic principle: save data by requesting and changing and downloading only the data that you really need. And that is a huge advantage when compared to traditional REST services where you use only get, put, post, and what was the last one? Delete, which act on the data as a whole and which can't, however, change data in small, tiny bits. With exceptions, depending on how you implement them, but these requests are meant to just change incrementally. The last HTTP method that I would like to mention here is the options request. And the options request, let me read from the text, allows you to ask the server what HTTP methods are supported for a specific resource. So you ask the server which HTTP methods are available, and then your front end, the web application, knows which, or the browser knows which methods it can access. The options request is usually sent automatically by the browser, and it's part of the CORS, the cross-origin request services, which deals with cross-domain requests. For example, you access Google, and the Google web server tells you to fetch a time from time.com, for example. That is not happening in real life, but that would be an example. And usually browsers block these requests, but depending on the headers, the server could respond that it's allowed to fetch requests from other domains. Usually it's not allowed to because this would be a security issue, but it can be set to be allowed. And the options request is then sent by the browser to check the other domain server for available HTTP or for available REST endpoints. This is all a security thing, but it's still really good to know. The options request, for example, eliminates the chance of one domain abusing another domain. For example, if I write an abusive piece of web software that says you first download my website, then my website is displayed, and then you have to send 10,000 requests to youtube.com, for example, to crash the entire system, to crash the application. And if multiple people, hundreds of people access my website, they will all send 10,000 of requests to YouTube, and this will then be detrimental to YouTube's health. So that's why options first, which is invoked by the browser, first asks YouTube, which methods are available that I can call on your end. And if YouTube says, hey, you can't request anything here, then the browser won't do that. So that's a security mechanism, and it's a great one. Okay. The next section is nuanced status codes. Many developers use 200 and 404. 200 is the success code. 404 is not found. And there are a couple more. But first, let's start with this small introduction. When you start sending a request to a web service, the web service responds with content or with some kind of response, and that response always has a code, contains a code, and that code can be any value. And the most common ones are 200, which indicates that the request you sent is a success. 404, which is very commonly known, is a failure, or it says that the resource is not found. Let's start with some advanced status codes, nuanced status codes. There is 201, which means created, when a new resource is created. This would be more specific to your situation. For example, on a Formula racetrack application, you create a new racing car. Then, of course, the backend could respond with a 200, with a success, but 201 would be more specific to your use case. The backend says the resource has been created. 202 is accepted. That is usually used for asynchronous operations, which means that your request has been taken in, it has been accepted, but the processing is still ongoing and not yet complete. The answer might come later through a WebSocket, for example, or there will be no answer, but still the request is accepted. 204 is no content. That is used when an operation is successful but doesn't need to return any data, for example, after a delete. The operation is successful but doesn't need to return any data, nothing to say, so no content. A delete is successful. Of course, you could again respond with a 200. Delete is a success, but it would be more specific to this situation if you respond with 204, no content. And then there's 400, bad request. This one is quite well known, I would say. I've seen 400s quite a lot of times. And 400 says, or the response code 400 indicates that the request sent to the backend is malformed. It's not a valid request, or the content of the request is not okay, or the formatting of the request. Something in the request is not okay. So the request, the backend responds with bad request. And a similar situation occurs with 422, unprocessable entity. 422 is often more appropriate when the request is syntactically correct but contains invalid data. Yeah. So in case of invalid data, you could also send a bad request, but it would be more specific to the situation. When you respond with 422, it's not processable. 429 is too many requests, and this code indicates that rate limiting, a throttling has occurred when you send too many requests to a specific API. It will block you and say, hey, dear front end, you are sending too many requests, or dear client, to be more specific, you're sending too many requests. There's also a mechanism to, throttle or to avoid the too many requests response, which would be by retrieving headers, but we will have a look at the throttling headers a bit later. Okay, so we've looked at a couple of advanced HTTP methods and status codes, and if you know these, you're already a step ahead of the crowd. If you can recall these codes from the top of your head, great. Then, let's have a look at some of these in a private browser tab in the using developer tools and the networking tab. So we will have a look at the HTTP content of this blog post. So let's say I access google.com. As we'll see, the network tab is being filled with requests. These requests, they represent whatever the browser tries to fetch from the server. And as you can see, there are a lot of GET requests. These are the classic GET requests, which everybody should know. A couple of POST requests. And as you can see, there are, if we sort by name, there are no other requests. So not even Google is using a patch request or a head or an options request at this point. I'm just opening the page. Oh, there is an options. So I'm just opening the page and not much has to happen. It's just retrieving data from the web server with some authentication, some content. But all web applications can be implemented using these basic requests. And there is the options request, interestingly. So it's this one. That's the request that asks the server which HTTP methods are supported. So let's have a look at these. At it. So there was an options request, and it was sent to this URL. And no, was it? Yes, to the Google API's URL. And the response contained these headers here. This is the raw header and this is a formatted header. And as you can see, the response contains the available options. So there's a delete option, a get option, head options, of course, the options method itself, a patch option. So Google implemented something using patch, also using post and put. So the server tells the browser at this point, okay, you can send me requests to delete something, to get something, to retrieve the headers of something, to request the options, okay, which is what we're doing right now, to patch something, to post something, and to put something. So great, we already know which requests are allowed. And it's interesting that there's a patch request. And yeah, let's check what happens if I search for the weather. Are there any other requests? There are still, again, get requests, post requests, no options requests, and no other requests. So the patch and the head requests occur only in very specific cases. In case I modify something on the server side, and it can be modified incrementally. So doing things on Google is not a good strategy for that. Okay, but that was a small example of the available requests. And for the status code, we can also have a look at these. These are depicted in the leftmost column, and there are a lot of 200s, as you can see. And if I can collapse this a bit, it would be easier to see. Yeah, there are a couple of 200s, but there's also a 204, and 204 is the no content. So there's a GET request to some service here, and it says no content. So the no content response is not only used with deletes, but also with gets. There's no rules to that, and it just must fit the situation. I think, I don't want to be wrong here, but this is about Google Ads services, conversion, something about how the ads convert, I would say, the Google Ads convert. And there seems to be no response, at least no response body. There's a response header, but no response body. Okay, so that was the 204 status code in action. And this one is a blocked request. Okay, but that's it. The other ones, let's see if YouTube does something. Yeah, there's a 302 and 304. Let's sort the statuses. So 301, can we have a look at what that means? Because that one is not included in this blog post. 301 HTTP status code. It means move. Of course, yeah. I should have known that as a website owner. That is a status code that indicates that the website, the URL, has moved permanently to a new address. And the point of that is to tell search engines that the domain is somewhere else, and it should update all the search results to point to the new URL. 302 might be related. Let's have a look. It's a temporary. What is it? It's a redirection response. Indicates that the requested resource has been temporarily moved to the URL. That's a temporary forward to a different URL. And 304 is not modified. You can, by the way, find all these response codes on the Mozilla developer docs, developer.mozilla.org. 304 is not modified. That's a response header that we will encounter later on when we will look at caching. But for now, we can skip this one. This one basically means that something on the server side has not been modified. A resource has not been modified, so the client already has the data because it was cached at the client side, or should have been cached at the client side, and the server is not responding to save bandwidth. Okay. Any other example? We have a couple of 403s, and looking this one up is a forbidden. So this means I am not logged in and need to log in to access the resource. Yeah, and I'm indeed not logged in. Here's the sign in button. Okay, but that's already it with the status codes. I could have included more in this blog article, I see, but still I showed you how to find out what a status code means and how to find which status codes your application uses, or the application of your interest. Then scaling APIs with caching. So what can you do with these status codes and with the, well, not with the methods, but you can do something with the status codes and the requests if you use them properly. And a big topic here is performance optimization. And the largest portion of performance optimization is usually caching. Caching means that the client stores data that it normally would request from the server. It requests the information once, and if the server says, hey, this is the information, I will send it to you right now, but for the future, store it. And don't ask me about it for the next 2 hours, for example. That is caching. And then the client does not have to produce requests, or it does not have to use up bandwidth to retransmit the entire information. Yeah, and for that there are cache control headers. These are typically present in HTTP responses. They can be present in the request as well, but are typically part of the response. And the response of any request, for example, of a GET request, usually contains a cache control header. For example, here, let's do the example side by side. So this request requests a file remote.js, and the response contains the cache control header saying cache control, public max age, and then this number. And this means when the browser receives this response header with the cache control, then it will automatically save this file in a local cache and store it for a specific time. This is the time in seconds. Probably it's 24 hours or 1 day. And public means this cache can, or this information, this file that we downloaded, it can be stored in a shared cache. It's not specific to the user that requested it. So this is a great performance improvement, and if you can implement it on your web service. Then there's of course also cache control no store. And let's see if we can find a request that answers no store. For example, here's a cache control private. This means, I guess, that I don't guess. This means that the cache, that the data can be stored, but it has to be private it has to be specific to the user. It's not going to be in a shared cache, which everybody can access. But the time is not specified here. So the caching duration is not specified. This means the browser can specify how, or can decide how long to cache it, or even if to cache it. Let's have a look if we can find a no store. There's cache control private, cache control, there's no cache control here. So probably that's a different representation of the no store if you have no cache control included. We can search for contents of responses using this small search icon here, and I can do a no store search. And there's a result. There was a request here. It's a GET request, and the cache control explicitly says no cache, no store, max age 0. So it looks to me like the response really emphasizes that this is not information to be stored by the browser, by the client, and needs to be refreshed, or in this case, revalidated every time. So this is not going to be cached, but almost all the other information can be cached in some way. Let's check here. Cache control public max age. I guess it's 1 day. Yeah, so we already learned something about caching. That's a basic principle of caching that the browser implements. All we have to do is implement in the backend service and the server side that it adds these header fields. And then the browser already knows, okay, I'm going to save this data and I don't have to request it again. Or I can request it, but the request is going to end the request is going to end in me reading my own cache, so I don't really have to look it up at the server side. Then there's the so-called e-tag and if non-match header flag. And these sound a bit confusing, I find, but let's have a look at the e-tag. I bet we can find one here, e-tag. And if we don't find one, we will in a couple of seconds. And let's first start with a small introduction. The e-tag response header allows a client to check whether a resource has changed since it was last fetched. So, as a client, I send a request to the server responds, and the response contains an e-tag, entity tag. Practically, that e-tag is nothing other than a simple version tag. For example, from some image database, I request a specific image, picture.jpg. And this picture.jpg response contains a header with a called e-tag, and that is the version, and the value of e-tag is going to be 1, or it might be 16,000. Whatever the version is, the client is going to store that version, and next time the client does a request or sends a request to the browser or to the server, the server checks the e-tag that is part of the request now. And if that request e-tag equals the e-tag on the server side, if the previous response and now the request e-tag are equal, then the server will respond with the status code. Where is it? It will respond with the status code, it was here, not modified. The not modified is linked to the use of e-tags and to do, of course, the request does not put the e-tag into the request header, but it puts it into the if non-match request header. So the server puts into its response an e-tag, and the client puts the value of the e-tag into the if non-match. And if there's no match on the server side, the server will respond with not modified. If there's no match on the server side, if there's no match on the server side for that e-tag, the server will respond because then the version has changed. But if there's a match, it will respond with the not modified. So it's a bit confusing to wrap your head around it, but once you once you understood it, it's quite simple. And of course, I also wrote I wrote the steps here, but I already described them in a much more confusing fashion. So let's go through the steps once. The server returns an e-tag value with the response. The client stores the e-tag and includes it in the if non-match header when making future requests. And if the resource hasn't changed, the server responds with a 3 or 4 not modified, saving the client from downloading the data again. Great. So now we're already caching experts. We know how to scale this application a lot better than someone who uses just the get, post, put, and delete requests. with these mechanisms, you can, with the caching mechanisms, you can be much faster in your web application. And with the patch request, even uploading new data or changing data on the server becomes incredibly fast, much faster than completely replacing the data using a put request. Then what's the next step? What's the next principle we can look at? Design principles for RESTful APIs. Resource modeling. Yeah, RESTful APIs have a URL. They are accessed somehow, as you can see here. By the way, we wanted to check e-tags. There is no e-tag here. But I know for sure that there are e-tags on YouTube. There are some. I just had to capitalize the E. So let's check it. This GET request contains the E tag. Where is it? Am I blind? This one says content security, but that's not the right one. The E tag should be in the response. Maybe it's just the wrong match. Yeah, for example, this is definitely a wrong match. Google tag matches E tag, but it's not a proper E tag. How can we find an E tag? Maybe maps.google.com. There's an E tag. Okay, so here's a response from Google, and the response contains this E tag. That means some resource has been transferred, some information has been transferred, and the version of that information is this E tag. And the next time the client sends a request, it will reuse that specific E tag and put it into the if non-match header. Let's search for that E tag. It's not used yet, but maybe if I refresh. If not, then that's just because I don't know how this has been implemented specifically. But if there's an E tag, there should also be a if non-match response. No, not here. What can I try? What else can I try? If non-match. Okay, but anyways, the E tag has been transferred to the client. Next time the client requests the same resource, it will put the E tag into the if non-match request. Yeah. How much else is there? Okay, let's look at, but at a faster pace. We're going through this too slowly. Let's look at design principles for RESTful APIs. First off, there's modeling. Of course, we have to design the URLs that we are going to use, that we're going to access and request from in a proper way. For example, the endpoint, a URL with a /users is going to look better than get users. Also, we don't need to do a get users or specify our URL endpoint as get users, because it's much clearer to access users and send a get request This is the same as a get users. By using get users, we would limit ourselves to get requests only. And if we implement other requests, then a post to get users it would not make any sense. Then keep your URIs intuitive and hierarchical. Users, ID, posts. Yeah, makes sense. Instead of what would be a stupid URL. Maybe date. The date today, 17th of September /user/whatever. A backend service where the data is separated by date would be, for example, completely unreasonable. It would not make sense. Then versioning. You can expect that your backend service is going to evolve, and for that it makes sense to version tag your URLs, for example, like this, v1/resource, or you can also add a service version to your headers. For example, in the response headers, if you access a service, it will respond with the version that has responded, or if you request from the server a specific version, then you can also do that. I find the URI versioning much clearer, but this is a matter of taste. It does not really matter. Let's see if Google or YouTube has something with V1. Yeah, there it is. So this is a very common one. There's metadata API URL YouTube I/v1. So you can see even YouTube does this, and it's not a bad practice. If YouTube does it, then it's probably not too bad of a practice. I mean, YouTube works. Okay, security and authentication. There are some authentication methods that you can use, some best practices. Let's skip those for now, or let's just read through them. Many APIs use OAuth 2.0 for token-based authentication. There I messed up the links. And with JWT, JSON Web Tokens, these are short-lived self-contained tokens that store user information and permissions. Yeah, so tokens are used for authentication. And then you can use signed tokens, these JSON Web Tokens, and they have to be signed asymmetrically. I guess that means by both parties. No, it does not mean that. Asymmetrically means that you have a key that encodes the whatever you encode, and then you need something else to some different key to decode it. That's asymmetric coding. Let's just, before I tell you something wrong, asymmetric coding. Very popular example is the Bitcoin private and public address. That's also an example of asymmetric coding. Anyways, don't take this coding things too seriously. I'm not an expert in coding, or at least not in signing and encryption. Then rate limiting and throttling, and that's what I talked about earlier. There's the response to many requests, which the server responds with if you send too many requests. And before that happens, it is a good practice by the backend, by the server, to respond with headers that indicate the rate limit. For example, if you send requests to a server and suddenly the server just says too many requests, you're blocked, that's not that good of a practice. You can do it, but I don't find it quite pleasing. It's better to warn the client. And for that, you use the rate limiting headers. The rate limiting headers include in the response how many requests are allowed in total, then how many requests you can still send, how many are remaining for you. And then there's a time, the rate limit reset, which is a time when the limit will reset. And through this mechanism, you can throttle the amount of requests that the client sends to the server. And if the client still requests too much, then the server will throw the 4 to 9 too many requests status code. Great. And last but not least, monitoring logging documentation. Especially when using REST APIs, there are so many great tools to just automatically generate documentation just based on the specification of the implementation on the server side. If you use specific annotations, for example, annotations that indicate the type of request and the URI, the URL of the endpoint, and annotations that indicate the format, all of this, then you can automatically generate based off that documentation. Of course, not human written documentation that says what's the point of a method or how it should be used, but more metadata based documentation, and you can generally get quite good documentation using OpenAPI Swagger API. For example, if you use Java and you implement REST endpoints there, then it will take the Java doc and convert it to REST endpoint documentation, which is very nice. I think it's JSON but it does support multiple formats. Then there are other tools like Prometheus or Grafana, which track request times, error rates, and server load. So this is for logging and metrics tracking. And these are tools that are also quite popular on the cloud side. For example, Grafana, I know, is supported by AWS. I'm not sure if it runs in the cloud. I think it runs in the cloud. But these tools are quite popular for logging and gathering metrics about your REST API. If requests fail, this will be tracked in these tools. And if they have performance problems, it will be tracked in these tools. So this is very, very, very good. Yeah, is there anything else? Then there's a testing tool called Postman, which is also used widely in software engineering, and Postman integrates with your REST API, and you can create automatic tests based on the REST API. As you can see here, Postman. Now the screenshot is gone. Here. Yeah, if you have a look here, Postman takes the resource URL, the resource identifier URI, and then you can send specific requests. Of course, there are free tools as well for doing this, but this one has automation, testing, all of these features that are widely popular. So these are some very popular tools that can be integrated with your REST API. And that's it. We had a very, very large outlook on all the different advanced HTTP and REST concepts. First, we had a look at different methods, then different status codes. My favorite topic was the caching and the eTag and if non-match tag, which are used to decide whether to request something from the server or no, whether they are used to decide whether the server should even respond to you or whether you can use your cache. And these are great things to know, in my opinion. And if every developer knew these things, we would save so many resources, so much bandwidth. This would probably reduce power consumption of computers a lot, or of web applications, and this would deep load a lot. So these are concepts which make your application faster, more scalable, use less bandwidth, so they are worth gold. And then we had a look at a bit of resource modeling, versioning, and authentication, rate limiting and throttling, which I found interesting as well, and some basic monitoring and logging and documentation. Yeah, that's it. I hope you learned something. I learned something as well, just by recording this video and explaining stuff to you and showing you everything in the browser here. And I hope you found it valuable as well. And I wish to see you the next time. Bye.